Unitree Go2. One example of state-of-the-art embodied AI is the Unitree Go2, a quadrupedal robot. With Unitree's own 4D LiDAR L11 technology, the Go2 is an interactive and versatile device with a price tag of $1,600. Because of this technology's 360° by 90° hemispherical ultra-wide recognition, the robot can easily traverse complicated terrains. Connectivity options include Wi-Fi 6, Bluetooth, and 4G, so you can use the app to send high-definition images and control the device from a distance. Go2 tasks are efficiently handled by its ultra-long battery endurance of about 2 to 4 hours. Its intelligent side-follow system, ISS 2.0, makes it better at following and interacting with humans. Online software updates can also be applied to the Go2. Impressive in its own right, this smart bionic robot represents the cutting edge of personal robotics and the potential of artificial intelligence as a companion. Festo BionicOpter. The dragonfly served as the inspiration for the Festo BionicOpter, which is an extremely lightweight flying item. In order to simulate the intricate flight properties of a dragonfly, this technological marvel has been created. The BionicOpter is capable of maneuvering in any direction, hovering in the air, and gliding without producing any motion with its wings. As a result of the lightweight design and the incorporation of functionalities like as sensors, actuators, and mechanical components, this is now feasible. In spite of its complexity, it may be operated in a straightforward and natural way with the use of a smartphone. It has been officially recognized by the Guinness World Records 2020 as the largest flying robotic bug that has ever existed anywhere in the world. Festo's dedication to bionic learning and the incorporation of nature's optimization tactics into engineering is demonstrated by this breakthrough. Atlas Boston Dynamics. Among Boston Dynamics' most notable creations is Atlas, a sophisticated humanoid robot renowned for its nimbleness and adaptability. Its sporting intelligence and real-time perception are the building blocks of its multi-function design for use in the real world. Through the use of depth sensors and a sophisticated control system, Atlas is able to swiftly and gracefully traverse complicated landscapes. The robot is 89 kilograms heavy and 1.5 meter tall, with a titanium and aluminum frame that gives it the best strength-to-weight ratio possible. Its small hydraulic system and bespoke battery allow it to do amazing things, like leaping and somersaulting. Atlas is not for sale, but it does provide a platform for researchers to test the limits of robotics. The quadruped robot Spot, made by Boston Dynamics, however, is priced at $74,500. You can tell their robotics technology is top-notch because of this. Festo BionicSwift. An revolutionary biomimetic flying robot, the Festo BionicSwift takes its cues from the Swift bird. This robotic bird was created by Festo, a renowned firm in automation technology. Its lightweight build and sophisticated aerodynamics allow it to simulate the flight qualities of actual Swifts. The ultralight construction of the BionicSwift, which includes carbon and flexible lamellae, allows it to execute quick maneuvers and tight bends, despite its relatively small weight of 42 grams. Precise control and varied flying patterns are made possible by its wings' ability to flap individually. The robot can navigate its own way around obstacles in a predetermined airspace thanks to its built-in GPS navigation system. The BionicSwift is an example of Festo's skill in fusing eco-friendly design with state-of-the-art technology. It could find use in automation, environmental monitoring, and aerial robotics, among other areas. Go2 Pi Robotic Dog. The Go2 is an innovative robotic canine that runs on a Raspberry Pi CM4. Being the first desktop-level robotic dog with an arm, it is sure to be a conversation starter and a treasure trove of tech memorabilia for any tech aficionado. To better resemble a genuine dog, this robotic companion has a 6 IMU system for increased flexibility and 12 degrees of freedom for omnidirectional movement. Equipped with sophisticated AI modules, it can hear, identify, and react to users. Even anyone without any experience can pick up and use the Go2 right away because to its intuitive design, one-button interface, and proprietary software. At $449 for the most basic model, it is positioned as an accessible gateway to autonomous robotic technology. Other variants of the Go2 are the Mini and Lite, which are priced at $749 and $449, respectively, with expected retail pricing of $1,398 and $898. Festo BionicFlyingFox. Inspiring by the Festo BionicFlyingFox, the lightest flying item with sophisticated kinematics, the Flying Fox is the biggest bat species. Although it has a wingspan of 228 centimeters and a body length of 87 centimeters, its weight is just 580 grams. Operating mostly autonomously inside predetermined airspace, the BionicFlyingFox makes use of both an internal and external motion tracking system, which are integrated into its onboard electronics. Its wings are articulated in a way that mimics the motion of the hands and arms, and an elastic membrane covers the entire wing from tip to tail. The flying membrane is sturdy, ultra-light, and made of 2 airtight films and knitted elastane fabric. It is also very thin. The BionicFlyingFox can match its natural counterpart's nimbleness and accuracy because to its design, which lets it control and fold its wings independently. Unitree H1. As a pioneer in the field of universal humanoid robots, Unitree has released their state-of-the-art H1 model. At around 47 kilograms in weight and 180 centimeters in height, it has a peak torque density of 189 Newton-meters per kilogram. An amazing 3.3 milli per second is the record for the H1's moving speed, and it has the ability to go faster than 5 milli per second. The 864 watt-hour battery gives it enough of juice to last, and the 3D LiDAR and depth camera provide it superior perceptual abilities. With its improved load capacity and endurance, an Intel Core i5 processor is the base model for the H1's computing capabilities, although additional alternatives like an i7 or Jetson or an NX are available for user development. As a contender in the humanoid robot market, its pricing is likely to be less than $90,000, albeit it is not disclosed. Festo BionicKangaroo. The Festo BionicKangaroo is a robotic model that was designed with the distinctive movement of a kangaroo as its inspiration. In order to imitate the natural kangaroo's capacity to increase speed without consuming additional energy, it is designed to recover, store, and utilize energy in an effective manner throughout each hop. In order to achieve its one-of-a-kind jumping habit, the BionicKangaroo makes use of a combination of pneumatic and electric drives. Rechargeable lithium polymer batteries, a portable energy supply, and either a small compressor or a high-pressure storage device are included in its assortment of features. Through the use of a specialized wristband, the BionicKangaroo may be operated through the use of gestures. This cutting-edge robot exemplifies how nature may serve as a source of inspiration for future technologies and concepts. Tesla Optimus Gen 2. A big leap forward in robotics technology is the humanoid robot known as the Tesla Optimus Gen 2. Because it uses Tesla's own actuators and sensors, it can handle fragile objects with ease, including eggs, without cracking them. In comparison to its forerunner, the Gen 2 model is lighter by 10 kilograms, has an articulated toe portion, and a 30% faster walk pace. It has 11 degrees of freedom and tactile sensitivity on each finger, making its hands more agile and quick. With a price range of $10,000 to $20,000, Elon Musk has announced the Optimus Gen 2, making it a more accessible alternative for future commercial and industrial uses. By making high-tech robotics available at prices comparable to those of human workers, this pricing model has the potential to radically alter the industry. A look into the future of automation and human-robot interaction is captured by the Optimus Gen 2, which is more than just a robot. Festo Emotion Butterflies. A remarkable example of bionic engineering is the Festo Emotion Butterflies. Collective behavior is displayed by these ultralight flying objects. Due to their highly integrated onboard electronics, these artificial butterflies can replicate swift, natural movements with precise and unique control over each of its wings. The butterfly's 2 infrared tags on its wings are used by 10 infrared cameras placed across the room to follow it. The butterflies are coordinated from the outside by a central master computer that receives the position data. An intelligently networked factory of the future may employ this control and monitoring system. In terms of minimization, lightweight design, and functional integration, the Emotion butterflies represent a breakthrough for the bionic learning network. They blend collective, coordinated flight behavior with the lightweight design of artificial insects. Festo Bionic Ants. The cooperative behavior of real ants is modeled after that of Festo Bionic Ants, which are robotic ants. These autonomous components demonstrate how a networked system can tackle difficult problems by communicating with one another and coordinating their actions and movements. The Bionic Ants are manufactured through the utilization of one-of-a-kind techniques, which involve the utilization of laser-sintered components that are augmented with visible conductor structures through the 3D MIDI process. The actuator technology of the legs makes use of piezo components, which are characterized by their precision, speed, energy efficiency, and almost complete lack of wear requirements. Each individual ant is capable of integrating a wide variety of components, technologies, and functions into a very tiny space. The cooperative behavior that is being observed offers intriguing possibilities for the development of further production systems. Festo Bionic Fin Wave. Marine animals with undulating fin movements, such as African knifefish and cuttlefish, served as inspiration for the Festo Bionic Fin Wave, an autonomous underwater robot. For propulsion, it employs 2 side fins that are entirely silicone molded. Because of their remarkable pliability, these fins are able to imitate the fluid wave motions exhibited by their biological counterparts. 2 internal servo motors propel the 9 little lever arms that hold the fins to the robot's body. In contrast to a regular propeller drive, the Bionic Fin Wave can produce a variety of wave patterns, allowing for more accurate and gradual motion with fewer eddies. Through its wireless connectivity, the robot can exchange data with the outside world, such as readings from temperature and pressure sensors, and send them to a tablet. Through an acrylic glass pipe system, the Bionic Fin Wave can move autonomously. MIT Mini Cheetah. Small and nimble, the MIT Mini Cheetah is a 4-legged robot that is well known for its dynamic movements and sturdy design. Although it weighs only 20 pounds, it is capable of doing a variety of moves that are comparable to those performed by a gymnast who has won a championship. It is able to walk in such a way that it is either right side up or upside down, trot over uneven terrain at a speed that is approximately twice as fast as the normal person's walking speed, and even perform a backflip from a standing position that is 360 degrees. The modularity of the robot was taken into consideration when designing each of its legs, which are powered by 3 identical, low-cost electric motors. In a manner similar to that of Legos, this makes it simple to replace individual components. Even in the event that a backflip results in a spill, the Mini Cheetah is designed to be virtually indestructible, meaning that it can recover with minimal damage. PTOY Robot Dog B. One such bionic dog is the little, quick and powerful PTOY Robot Dog. It's a programmable robotic pet that can be used to boost STEM and robotics education. It's open source. Impressive performance is delivered by Bittle, despite its diminutive size. If you want to study, train, or experiment with quadrupedal robots, this is the way to go. It has a variety of visual sensors that can be attached. A specialized Arduino board that can interpret both simple and complex hand movements controls it. A smartphone app allows you to control Bittle, and it may be built using Python, C++, or block-based coding. This paves the way for AI applications, robotics, the Internet of Things, and exploration in the real world. This set comes with a Li-ion battery pack, a wireless dongle that can connect to Wi-Fi and Bluetooth, 8 servos that can walk and pan the head, and more. Highwonder Spider Pi. Robotics expert, Highwonder Spider Pi uses Raspberry Pi 4B to power its sophisticated hexapod design. Hexapod robot motion control, machine vision, OpenCV, and deep learning research will benefit greatly from this platform. 20 kilograms of torque are provided by the robot's clever serial bus servos. Several artificial intelligence vision applications can make use of its wide-angle HD camera. Python is a language that the robot can be taught to use. A live camera feed and smartphone control over the robot's movements are also supported. A variety of tripod and quadruped gait styles are enabled by SpiderPi through the use of inverse kinematics. Aside from being able to modify its speed and direction of motion, it also has an adjustable height. The versatility and creativity of SpiderPi make it an ideal tool for investigating AI and robotics. Hexapod V2, an advanced robotic project known as Hexapod V2, is comprised of a 6-legged robot with 3 joints on each leg, resulting in a total of 18 degrees of freedom for the robot. A 2S LiPo battery is used to power it, and Bluetooth Low Energy (BLE) allows it to be operated remotely through a mobile phone, either iOS or Android platform. All of the body parts are created using a 3D printer. Linkit 7697 is the controller that is being utilized for this project. Alternate movement modes such as shift, climb, and slow are also included in this feature. Every resource, including 3 DSTL files, PCB schematics, and 7,697 source code, is accessible on GitHub. The project is open source, and all of the resources are available there. Due to this, it is an excellent platform for makers and hobbyists to investigate advanced robotics, kinematics, and programming that is available. PTOY Robot Cat Nibble. With its open-source architecture and cutting-edge technology, the PTOY Nibble is a groundbreaking robotic cat that combines the two. Additionally, it is the quickest and lightest feline robot in the world. You have complete control over Nibble's behavior because its movements and personality can be programmed from your end. Because it saves instinctive muscle memory to move about, it is driven by a microcontroller that is compatible with Arduino. It is possible to put an artificial intelligence chip, such as Raspberry Pi, on top of Nibble's back in order to gain assistance with perception and decision-making. 11 joints are present in the robot, which is constructed out of wood. It measures 250 millimeters in length, 107 millimeters in width, and 140 millimeters in height. A Li-ion battery pack that has a capacity of approximately 1 hour is included in the package. Festo Airacuda. One example of a bionic fish is the Festo Airacuda, which is operated by remote control and powered by pneumatics. Propelled by a mechanical fin drive, its design, operation, and structure are reminiscent of fish. The fluidic muscle that powers the fin drive mimics the action of the fins on the tails of many fish species. The Airacuda is able to propel itself through the water by harnessing the power of the fin ray effect, which it exploits in conjunction with its fin stroke. Like its archetypal aquatic counterpart, it maintains its equilibrium with the help of an air bladder. You have the option to fill the inside cavity of the hull with air or water. In order to control the flow of compressed air or vacuum into the air chamber, a pressure sensor measures the depth and transmits a signal to the electronics. With just 4 actuators, the Airacuda can do all of its maneuvering. Festo Aqua Penguin. This autonomous underwater vehicle, known as the Festo Aqua Penguin, was designed with the natural design and behavior of penguins as its inspiration. As a result of its hydrodynamic body contour, it is able to turn on the spot, maneuver in confined places, and even swim in reverse. The portions of the Aqua Penguin that are responsible for wings, head, and tail can move in any direction. In order to navigate and prevent collisions, it employs a specialized 3-dimensional sonar system, which is analogous to dolphins. An innovative new development in the field of robotics is the hull design, which is based on a flexible structure called a fin ray and was inspired by the tail fin of a fish. In the sphere of handling technology, this design has the potential to open up new application fields. One example of how the efficient designs found in nature may serve as a source of inspiration and help progress technology is the Aqua Penguin. Festo Aqua Jelly. An electric motor unit and an intelligent adaptive mechanism give the Festo Aqua Jelly its autonomy and make it an artificial jellyfish. The swarming behavior of real jellyfish is mimicked. The Aqua Jelly has 8 propeller tentacles, a core waterproof body, and a see-through hemisphere. The electric motor, 2 accumulator batteries made of lithium-ion polymer, the charging control unit, and the swash plate actuators are all housed in the center component. Based on the fin ray effect, the tentacles mimic the biological model's peristaltic forward motion. Weight displacement controls the Aqua Jelly's movement in 3-dimensional space. To make sure all the jellyfish have enough juice, it talks to a charging station. By coordinating their strategies, the Aqua Jellies can tackle challenges of a grand scale. As a result, Aqua Jellies can serve as a springboard for additional research, such as studies on collective behavioral patterns.